Check it.
Okay, welcome back. Today we're going to be talking about graphing exponential decay functions. So last time we graphed exponential growth functions, and now it's going to be decay. Now what does decay mean? Decay means something decreasing. Okay, growth means growing and decay means decreasing. So let's just talk about how exponentials work for a second so you can understand why these things look the way they look. Now, an exponential function looks something like this. Y equals b to the x, all right? And b is your base. So for instance, y equals, I don't know, 3 to the x. And as you make a table for something like this, you have, let's say 1, 2, 3, 4, 5. This is going to be 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, and 3 to the power of 5. And what that really means is, if you think about it in terms of multiplication, this is 3, this is 3 times 3, this is 3 times 3 times 3, and you get the idea here, right? Like that. So this is growing. It's getting bigger and bigger because you're multiplying a number that's greater than 1 times itself over and over and over again. Okay? Well, what if this base was less than 1? I don't mean negative. I just mean like a half or something, like a fraction between 0 and 1. A positive number, but still less than 1. So what if you had something like, I don't know, instead of 3, what if you had like a half? Okay, now let's make a table for that. All right, and we'll do the same thing. 1, 2, 3, 4, 5. So this would be 1/2 to the 1, 1/2 to the 2, 1/2 to the 3, so on and so forth, right? Oops, 1/2 to the 4. Like that. And what this really means is, once again, 1/2. And this is 1/2 times 1/2. 1/2 times 1/2 times 1/2. You get the idea. So the question is, are these getting bigger or smaller? 1/2, think about a pizza, is half a pizza. But then what's 1/2 times 1/2? Isn't that 1/4? Isn't that less pizza, right? It's a smaller number. So you're starting off with 1/2, now you're at 1/4. 1/2 times 1/2 times 1/2 is 1 over 2 to the 3rd power, which is 1/8. This is 1 over 2 to the 4th power, which is 1/16. And this is 1 over 32. These are getting smaller. So this is what we call decay, exponential decay. And this is exponential growth up here, okay? So hopefully you can see the difference between these two situations. When your base, this number right here, is greater than 1, if b is greater than 1, this is exponential growth. But if your base is less than 1, and I'm not talking about negative, I'm just talking about less than 1. So if I really want to be accurate here, or really want to be complete, I should say if your base is between 0 and 1, like that, then you have exponential decay. And that's how you can tell them apart. Okay, you look at the base. So that's what this function here says. Or rather, these notes here say. If your b is greater than 1, sorry, this is actually wrong. This is supposed to be the letter b, not the letter x. Okay, so yeah, if your b in here is bigger than 1, then you're growing. If your b in here is less than 1, like it is here, you're shrinking. Okay, you're starting high and you're coming down low instead of, okay. So how does this look like on a graph? Okay, so in the last section, we learned how to graph things like that, for instance, right? This is the stretch. This is your exponential. Well, here we have a stretch. We have a stretch of 3. there aren't any shifts, any you know, vertical or horizontal shifts, but we do have the exponential part right here. Okay, and so we're going to make a table. -1, 0, and 1 are still the numbers we're going to use for exponential decay, no different than before. So that's good news. And now you might be thinking, okay, what is 1/2 to the power of -1? That might seem difficult to you, but the truth is it couldn't be easier, because 1/2, anything to the -1 power just means flip it upside down. So what's 1/2 flipped upside down? 2/1, also known as 2. What's 1/2? We're just doing this part here. We're not worried about the stretch yet. What's 1/2 to the 0? Anything to the 0 is just 1. And what's 1/2 to the first power? Well, anything to the first power is itself. So even though we have fractions here, this is really simple. Okay? You don't have to worry about, you know, this being difficult, this part at least. Now, you have to apply the stretch, and the way we did it last time is the same way we're doing it now, which is we multiply the stretch times the y column after we're done making our table. So now this becomes a 6, this becomes a 3, and this becomes 1/2 times 3 is 3/2. Okay? Okay, now for the sake of graphing, if you don't know what 3/2 is, it's 1.5. So it's good to know what the decimal is when you're graphing, because you need to know where to put things. Okay? Now, there are no shifts to worry about, so I don't have to move my x-axis or my y-axis. I'm going to use the regular origin because there are no shifts here. And let's see, we've got -1, 6. So starting from here, -1, +1, 2, 3, 4, 5, 6. We're starting way up here. 0, 3. Well, here's 0. We're going to go 1, 2, 3. And there's that. Then 1, 1.5, or 3/2. Here's 1, and then up 1.5 would be right about there. Now, if you remember, in the last lesson, we had 3 points, but those 3 points, when you drew them, either went up like this, or if it was a upside down flipped kind of thing, it was going down like this, right? That was the 2 kinds of functions that we learned to graph last time. Now, this obviously does not fit that pattern, right? This does not go up like this or down like this, right? What this does is the opposite. Instead of going up like this, like a plane taking off, for instance, this is going to come down like that, like a plane landing, okay? So if you read your graph from left to right, like you're supposed to read your graph in English, right? From left to right, a growth function from left to right goes up. A decay function starts high and comes down. That's the difference, okay? Growth in red, decay in blue. That's the difference. They look otherwise the same, but one starting high and going low, that's decay. One starting low and going high, that's growth. So since we're learning about decay functions right now, you're going to see that this function starts high and comes down. So you still have a half parabola, but instead of it going up and to the right, it's actually going, it's coming from high up and it's coming down. So I know I'm drawing it, it's easier for me to draw it this way, so I'm going to draw it to the left, but really have to think of it moving, it's moving this way, right? It's coming down. And then from here, you just land the plane on the runway, which is the horizontal asymptote here. So nothing new really here, except for the fact that it's coming down instead of going up. Otherwise, it's exactly the same situation as the growth functions. Okay, so what's the domain and what's the range? Well, the good news is that the domain has not changed. It's still all real numbers, okay, because the x's that this function travels through are all the x's, all the positives, all the negatives, and everything in between. The range, on the other hand, you can see you don't travel through all of the y's. You never go below the x-axis. So you never go below, this is y equals 0, right? You're up here, but you're never down here. So your y's have to be greater than 0, and that's your range. Okay, so everything is the same as it was with the growth functions, except for you're starting with a number that's less than 1 in here, meaning a fraction, like 1/2 or 2/3 or 3/5 or whatever, something that's less than 1. So the function is coming down instead of up. That's the only difference. Everything else is exactly the same as the last lesson. Let's try another example here. Okay, so we have here a function. It's got a base of 1/4. Because it's less than 1, because the base is less than 1, we know this is an exponential decay function that should be coming down. Okay? We also see that it has a stretch here of 1.5. All right? So let's make our table. Our very easy table. -1, 0, and 1. What's 1/4 to the -1 power? 4. Because it's just 4/1. What's 1/4 to the 0? 1. Because anything to the 0 is 1. What's 1/4 to the first power? Itself, 1/4. So very easy right there. And then here, we're going to multiply everything by the stretch, just like we did before, 1.5. Okay, I'll use decimals, I guess. If you're given decimals, you can use decimals, but we usually avoid them. So in this case, the problem gives you decimals. You have permission to use decimals. All right, so 4 times 1.5 is 6. 1 times 1.5 is still 1.5. And this is 1/4 times 1.5 is 3/8. I guess in decimal that would be 0.375. Okay. All right, so now we're going to graph our thing. Now, do we have any shifts? No, actually, we don't have to move any axes. We're just going to plot this here. So -1, 6. Again, actually, just like last time. -1, up 6. 1, 2, 3, 4, 5, 6 is right here. 0, 1.5. Here's 0. Up 1.5 boxes is right there. And 1, 1/4. Here's 1 on the x, and 1/4 would be right about there. And hopefully you can see that same half parabola, but this time it's going to the left instead of to the right, which is the difference between a growth and decay function. The half parabola is going in the opposite direction. Okay? And here, you're just going to land the plane. Do your best not to touch the, oops, I kind of hit it there, so I'm going to try again. That's why it's good to have an eraser in math. All right. And there you go. What's my domain? All real numbers, just like before. What's my range? Well, it's actually very much like the last problem, so it's actually y is greater than 0. So hopefully you're getting the sense that this is actually pretty simple and straightforward. Okay, let's try another one. All right. Now this one has some shifts in it, okay? This one has a vertical shift of +1, so you're going to move up 1, and it has a horizontal shift of right 2. Okay, so this means before you plot your points on the table, you need to draw new axes, right? So here we go. My horizontal axis is going to move up 1 space. Now, how do I know it's the horizontal axis? Let's just talk about that for a second. If I try to move a vertical axis up and down, up 1, will that make any difference? If I move this, okay, up and down, it doesn't change anything, does it? Right? The y-axis still goes up and down forever and ever and ever. So moving it up and down doesn't do anything. The y-axis should only be moved left and right. Okay, so obviously when we're talking about moving up and down, we're talking about the x-axis, not the y-axis. Right? So this is the axis that we want to move up and down, which is this one here. And we're going to move it up 1. So we're going to move that up 1, and that's our new x-axis. Okay? And the y-axis is to the right 2. Okay? So I need to move that. Here's where it started. Here's the y-axis, right? The original place. And we're going to move it over 2 spaces to the right. So now we have our new x and y axis. Now these have to be drawn as dotted lines. So since my thing doesn't do dotted lines automatically, I'll just take an eraser and chop it up into dotted lines. Like that. Okay. And here as well. So there are my new axes actually. And all the points that I'm going to graph from the table are going to go on this new XY axis, not the old black one here, but the new red one. Okay, so if you take away the shifts, we already took care of the shifts by doing this, then what's your function? Your function is just y equals 1/3 to the x. That's the parent function. Okay, because you've already dealt with this and you've already dealt with this, right? So that's all that's left is y equals 1/3 to the x. Okay, and we'll make our table for that. So -1, 0, and 1. 1/3 to the -1 is 3/1, which is 3. 1/3 to the 0 is 1, and 1/3 to the 1 is 1/3. Okay, and now you're going to put these 3 points on your new axis right here. So -1, comma 3. We're going to come over here. We're going to go back -1 and go up 1, 2, 3, and there's your point right there. 0, comma 1, starting from 0 right here, up 1. You're right there. And 1, comma 1/3. Okay, so here's 1, and we're going to go up 1/3 of a box, which is right about there. Okay. Now, hopefully you can see your sideways parabola going to the left because this is decay. All right. Would have been going to the right if it was growth, but it's going to the left because it's decay. And draw that best that you can. Make it look as much like a parabola as you can. No straight parts, all curve. Right? And there it goes. And on the right side, we're just going to land the plane, right? Get as close as you can to the asymptote without actually touching it. And there you go. What's your domain? As usual, all real numbers. What's your range? Well, this time you can see that we go as low as 1, y equals 1. That's what this line here is, y equals 1. We don't go below it, we don't touch it. So everything is above y equals 1, so the range is y is greater than 1. And that example is done. All right, last example down here. Let's try one more. This is as complicated as I could make it. Okay, we've got a little bit of everything here. We have a vertical shift of down 2. We have a horizontal shift of left 1. And we have a stretch of -2. Now, when the stretch is negative, it also means what? It means flip as well. So instead of this function coming down and landing this way, it's going to be upside down. It's going to be starting from down here and landing this way. It's going to be upside down. So you're taking this and you're flipping it, right? So this is a flipped decay function because of that negative there. So just be ready for that. Okay, so if you take away all of the shifts and flips, your parent function, okay, your basic function that you're going to make a table for, is simply y equals 2/5 to the x. That's all we're going to worry about with the table. The rest of the stuff we'll put on, well, in different ways. Like for instance, the down 2 will take our ruler here and go down 2 from the x-axis and make a new x-axis down here. And we'll make it a dotted line. Okay, and we'll make a new y-axis where left 1, so that's going to be here. All right, and there we go. All right, and this is the method I recommend, drawing your shifted axes first and then just plotting the points of the parent function on that. You could do it by making a table and plugging in all this stuff here, but I think it's a lot more difficult. So if you have a tutor that's saying, hey, that's not the way to do it, there are more than one way to do things, and this is the much easier way. Okay, so I've taken care of my shifts by putting down these axes here, so now I can pretty much ignore that and ignore that. Okay, and now I'm going to make my table. So let's see. X and Y, -1, 0, and 1, still the same 3 x's that we're using here. 2/5 to the x, when x is -1, well, 2/5 to the -1 is just 5/2, just flip it upside down. 2/5 to the 0 is 1, because anything to the 0 power is 1. And 2/5 to the first power is just 2/5, it stays the same. So that's done. There is a shift, the shift is -2, so you're going to multiply all of these by -2. And that'll take care of the flip, by the way, automatically. You don't have to do anything separate for the flip. Now, let's see what we get. 5/2 times -2. Well, these 2's are going to cancel out, so all that's left here is -5. 1 times negative 2 is negative 2. And here, 2 times negative 2 is negative 4 over 5, so negative 4/5. Now, if you want to know what that is in decimal, it's negative 0.8, 0.8. If you want to know where to put it, okay? All right, so starting with our new origin right here, negative 1 comma negative 5 would be negative 1 comma down 1, 2, 3, 4, 5. That's way down here. That's our first point. 0 comma negative 2. Well, here's 0, down 2 is right here. And 1 comma negative 4/5. Well, starting from here, 1 is 1 box over, and down 0.8, negative 4/5 would be right about there. Now, hopefully you can see the half parabola is right there. There it is. And as I told you before, it's going to be upside down. So the plane is under the runway instead of above the runways. You know, that whole metaphor there. So there you go. Like that. A little awkward, but okay. And now we're going to land the plane, but the plane is upside down. So we're still doing the same thing. It's just going to be upside down. So land the imaginary plane here without, oops, I'm getting too close to the asymptote. I'm kind of hitting it. So I'm going to back up a couple steps here. Okay, use your eraser. Use a pencil. All right, and that's good enough right there. So what's my domain? Well, still all real numbers. That didn't change. What's my range? Well, this time we're below a line here, right? This is y equals negative 2 over here. Okay, this red line here. And, oops, actually, I can't put it there because it's in my way. Okay, but this line right here is y equals negative 2. And we're below it. So I want all the y's that are below negative 2 but not equal to. So I say y is less than. All the other ones were greater than. This one's less than negative 2. Okay? That's everything. See you at the next video.
Check this.